So you have a couple of different scenarios here. This is the one where you're given a graph and you're supposed to come up with the equation. Okay, what do you think you're going to have to do here to come up with the equation? Get the points from the graph. Okay, get the points from the graph. And on top of this page, I'll just tell you this. For a linear, you need a minimum of 2 points. For a quadratic, how many do you think for a quadratic? 3. For a cubic, 4. Okay. However, I will say do everything that shows up. Okay, if you're able to extract more, do it. But more than likely, they will not give you more than what you absolutely need when it comes to a graph. Okay, so extract points from a graph. So you kind of have your x and your y. And we know that x is degrees Celsius, right? And y is sorry, I mixed it up, Celsius, right? And x would be months, right? Month of December, days, yes. The specific day in December, yeah. So, what's that one right there? I kind of made them very visible. That is 0, 6, right? 0, 6. And then 6 goes with, what would you say? 9, right? Would you say 9 point, oh yeah, 9.5. That's right, it's between 9 and 10, yes. 6 is 9.5. And then here you have to guess, right? So you have another clear point right here at 22, 0. And then you have another one here at 28, 0. Okay? And then you have everything you need. You put this into L1, you put this into L2. Stat, calc, what regression are we talking about? Cubic, right? I hope at least you agree with me on that. And then you just come up with the equation. So let's do that. Clear everything. Stat, edit. We can look at the scatter plot if we want. I'm going to go zoom 9. And it does reflect what we see on this graph, right? So we're good. Let's find the regression. Stat, calculate cubic regression. If you've done this in grade 11 applied, you know the buttons already, probably by heart, but if you need to write this on your study sheet, do that. And make sure, in this case, if we round it to 2 decimals, it would be 0.00. So grab a third, okay? Never have a 0 value for the leading coefficient. Minus 0.13x squared plus 1.28x plus 6. There we go. You have your equation. If you graph it, you see that it's going to work out just fine. Okay. Determine the temperature on December 16th. December 16th, according to this, December 16th is right there. Okay. So what are they giving us? They're giving us the day. They just want to know what the temperature would have been. So we go second, trace, value. We let x be 16, and we'll figure out what the y value should be. Second trace 1, 16, and the temperature is 4.01. And all you need to do here is make sure you have the right units. So we're talking degrees Celsius, right? Which day or which days was the temperature at or below 4 degrees Celsius? Okay, so what do we have here? This is referring to temperature. So we will let y2 equal to 4. Okay, and then we're going to find those intersections. Can I just, I'm going to make a change here. I'm just going to say which day or days is the temperature 4 degrees Celsius. We're just going to, not the below. We're just going to go at 4 degrees Celsius. So if it was below, we would have to consider a whole bunch of days. So you just enter that, let y2 equal to 4. And look at this. We don't care about what is on the negatives here, negative quadrant 2, but the line goes here, it cuts through there, and then it will cut one more time over to the right. So I'm going to investigate that. I'm going to go window, x max, I'm going to go 35 or something like that till I see that crossing. There we go. So we'll figure out this one and that one. See what we find. The first one is 16.014, and the second, I'm going to jump and just go across, is 31.95. 4. And there's a problem with this, right? December does not have more than 30. Is it 31? 30? It's 31. It's 31. I always do the knuckle thing. Because in between is 30, knuckle is 31. It's 31. So this one is out, right? This would be definitely like almost already the 32nd day. So we omit this one. Not December anymore, okay? So we would just say on day 16, okay, the temperature is at 4 degrees Celsius on day 16. Or you can say December 16th, if you'd like. Oh, it says it right there, December has 31 days. So now the domain and range. So basically, technically, if we go back to this graph, if this is supposed to represent what happens in December, we would say it stops right here. Okay, stops. It's only valid until that point. So we will state our domain and range based on that. So let me just do that real quick here on the side. You go like this, you go below and over. So it stops right here for us. So we know the x value is 31. We don't know what the y value is, but let me see here. Do we need this y value? This point is going to be even higher than that one, because remember, range only cares about what's happening from the lowest to the highest. So for the range, we need this and this. We need to only consider these 2 points. This one, we don't really need the y value for this point, not necessarily. You could find it if you want. So for domain, we would go from 1 to 31. Okay? And for range, we have to figure it out. Okay? Let's go find this high point and the low point real quick here. Second trace max. Actually, since I went with max, I have to go to this point here first. It is, we already knew what that was, but it is 9.5, right? 5.92, 9.5. And the low point, we have to figure that out. Second trace 3 min, right? We go to the low, somewhere to the left of it, and then somewhere to the right of it. And this one here is 25.16, right? This is negative 0.74. So this question could have asked you, on which day is it the coldest? Like, what's the coldest day? Go ahead and find this, and you would say December 25th. Round to the nearest whole number when it's like that. So for the range, we go as low as the temperature, the coldest it ever gets is that, the highest it ever gets is 9.5. Okay, so there you have your domain and range. Okay. I want to do 43 as well. I don't know if anybody got to that point, but I need to address it because it could show up. The volume of a box is actually quite common. So do 43 here. The volume of a box design made from cutting and folding a pattern was as follows. So here you have the width of the box as you fold it and the resulting volume. What type of function do you think best fit the relation between the width and the volume? Can you predict that? Volume is in what kind of units? Cubic units. We can predict that this will be a cubic relation. Okay. So can you follow me on this? Because there's the graph part that I need to explain on this one. So if all else, just make sure you follow by taking notes, okay? Stat. I will clear that and just enter. This always goes into L1, right? The first value, which is your X, and L2 is our Y. There we go. Stat. I'm going to do a zoom 9. I'm going to do a. And at first glance, you may think this is a quadratic, right? Because it does this and then down. I don't know if you can see it. It does kind of appear doing this, but in this case, I would just say because it's volume, you have to say it's cubic. Okay, so sometimes you just have to know what's what. Okay, because we're dealing with volume, okay, it is a cubic relation or function. Okay. So let's determine the equation of that will result in the line or the curve of best fit. I'm just going to go to my home screen. I already did a cubic relation, so just copy paste that because it will use your new entries for L1 and L2. It speeds that up quite a bit. And there you have it. So stat calc cubic reg, and this is negative 0.002 x cubed plus 0.06 x squared, and everything else is 0. Okay, so you're really just down to the x cubed and the x squared term. And now you graph it, just to have it on your screen, right? And you need to adjust your window. You need to adjust your window. So the zoom 9 only gets you to the points. What will you change your x min? It depends. I'm going to go -5 and see what that looks like. With my y min, I'm going to go -5 as well. Hit graph one more time. So now you see more of the cubic piece here. I would encourage you to keep chasing the curve to the right here. So I'm going to go to my window and change the x max to, let's say, 50. Okay, so there you have it. I'll tell you this, okay, listen carefully. For a cubic, we only care about quadrant 1. So as soon as this thing hits the x-axis again, we're stopping. Even though back here you may have another turn going back up, you never worry about it. We only consider it until it hits the x-axis once, because you can't have a negative volume, and it turns out that anything past it is not going to be acceptable. Okay, so the maximum volume is found right here. Okay, so let's find that second trace max. There's our max volume. Max volume, we're going to just say we went second trace max, and we came up with 28. So it turns out that the maximum volume is actually in our table, but we didn't know that for sure, right? So we would just say 8 liters is our maximum volume. What's the width that would give this volume? Well, remember, what is your x value? Your x value is represented by, or represents the width. So the width would be 20 centimeters. Okay. So the width of 20 centimeters gives you the maximum volume of 8 liters. Next, what width would yield a volume of 5 liters? Show how you determine this answer. They're asking for width, they're giving you the volume. Okay, that's basically what's happening here. So every time you got to go y2 is equal to 5. Second, trace, intersect, and figure out what the x value is at that point. Okay. Y2 is 5. And notice what's happening here. This goes back to the quadratic one last year with the areas. It happens twice. Okay, so we need to find both of them. Second trace 5. Let's find the first instance, which is 11.68 centimeters, or 26.42 centimeters. So I found both instances, both widths will result in the same amount of volume in the box. Okay. I want you to, when you think of this problem, I'm just going to tell you to follow me a little bit here, a couple pages down. Go to 54. 54. We're not going to do that today, but this is the idea that's happening here. Okay? 54. Imagine you have a piece of cardboard like this, and you're cutting out the corners. because then this part right here that flaps up, all of these side pieces will fold up, and then you have your box. The bigger you make these cutouts, the deeper the box is going to get. Okay? Like if you cut it, don't do this right now, but if you cut out bigger corners, right? All of a sudden, this box that you're going to fold is going to be deeper. So as you're changing this thing increases in volume, but then there's a point where it actually decreases in volume again if you cut out too much. So that's what's happening in this graph right here, is that as you make the width bigger and bigger, the volume gets bigger and larger up until a certain point, which is 8 liters. After that, it actually starts decreasing until you actually have 0 volume left, because you're cutting out so much, there's no cardboard left to make that box, right? That's what the idea here. Okay. Let's graph this. It is important to have at least one of these. I don't think it's necessarily going to show up, but we never know. So this will be your width in centimeters. And this would be the volume in liters. Okay. And you got to find the important points. Mr. Dirksen, can I use these ones? Can I use the ones that they provided me with? Yes, you may use those. Whenever they give you a table, they actually allow you to use those. So if that's what you want to do, you go for it. Okay. The only thing I would caution is that you need the x-intercept here. So I will find that. Second trace 5. Sorry, we need to let y2 equal to 0, right? If you want the x-intercept, if you want that x-intercept. Second trace 5, I'll just quickly find that one. That is 30, 0. So x-intercept is 30, 0. Okay. So here to make this fit, I'm going to go 5, 10, 15. That's not going to work. So I'm going to go 10, 20, 30, 40. Okay. And now you got to work on the volume. The highest volume is 8, right? So 2, 4, 6, 8. That's going to work. 2, 4, 6, 8. So this is your origin. 0, 0. I know this is 0, 0. Why? It's important that you know why. What's the constant? What's the y-intercept in this case? It's 0, right? So 0, 0 is your y-intercept, which is also the x-intercept. And if you don't know for sure, just use your calculator to find that one. So I know I'm here, and I'm also here at 30, 0. And then there's stuff in between. So I can use 5, 1.25. This would be 1. 1.25 is right about there. And then 10, 4. I can use that. 15 is right halfway here. 6.75. That'll be right there. 28. And then 25, 6.25. It's right about there. So that's enough to make that graph. Okay. I will just make a note. Okay. For volume, we always stop here. Okay, I'll just make that note for you because the graph obviously continues down here and maybe may curve back up. We don't care. We stop it right there. Okay? Always. All right. What's our time like? I'm going to go to the story questions. I know you're tired, but I need to get this in today, okay, guys? I need to get this in.